Let's start from me. Last week I managed to implement the load PGS in for OSD, so we can the load the PGs from from the from the object store persist created by memory a memory store. Chumi, could you could you mute?
Yeah.
There's some background noise out there. Thank you. I think the next step is to find a way to implement the read path of incremental OSD and to review the area cache. I have been reading a little bit, but didn't make much progress. If it's possible, Jianpeng, probably we can discuss a little bit offline at your convenience. And I just learned from Ricardo that they have pretty much feature-wise completed the Messenger v2 implementation. Probably we can catch up with them. I think that's me. How's it going, Tremay?
I'm working on the IO path and
Cool.
try to remove the queues, and I found a little complex because in the existing Ceph OSD, when they need to wait for something, for example, wait the OSD map or the PG created, it can just enqueue the operation and do other jobs. But for
Yes.
us, if we remove the queue, we should return future, and then that job will be stopped. So we couldn't start a task along this path, because we need to stop the job there, waiting for the future to be available. So I'm thinking about how to arrange the logic,
Yes.
because
Did you
the existing. You
yes.
understand me? Yeah.
Partially. Actually, I've been trying. When Redo after Redo presented us with the fast read path his prototyping of with the existing OSD. I sketched a preliminary implementation of a read path just in pseudocode on the Etherpad. I posted a link in his PR, and I was thinking about if we can we if we could to just return continue future if is the operation or the OP is blocked by some unfulfilled precondition. For example, if it is waiting for appearing PG, or if it is expecting updated OSD map, etc. If we could return that future and continue on once the unmet precondition is fulfilled, then we need to have a bunch of shared future preset as a member variable of a PG, for example, and fulfill the future once the precondition is fulfilled. So the future the promise could be fulfilled, and the OP can be resumed, but it's that idea is not necessarily correct because assuming we have like three preconditions we need to fulfill before execute the OP. For example, the paired PG, the updated OP, or the object it is in this context is not missing or is not being held by a scrub, being locked by a scrub. We cannot assume that the three precondition is still can be still fulfilled if the pending one can be triggered. So we need to go through them again once the last one is fulfilled. Am I clear?
Yes.
Yes. So we definitely need to do the same dance when the last precondition is the pending precondition is fulfilled. So we need to have some sort of a queue or sort of things. Yeah, we need to put it another way. We need to replicate the logic in the existing OSD in one way or another in the Kubernetes OSD. So I tend to agree with you that we need to feasibility to do something like.
So you agree that we still need to keep some queue, right? So if we for some condition is not available, we return a future. So all the job is scheduled by the SeaStor reactor, and we have to multiple entries to go to the IO path. For the existing code, maybe they one entry path, they just include the operation and do another task. For the only entry, they can do multiple tasks. But for us, we need multiple entries to trigger the tasks.
What do you mean by tasks?
For example, if the OSD map is not available, and they just include the operation, and then they can do some
continue on with another
continue on the same path and do the other tasks, because there are other some operation needed to handle something on commit or something, what else for the PG something, so they can do the other tasks. And the next OP is what's it? The OSD map is available. They trigger to check the waiting queue to see to handle all the operations waiting for the OSD map. The job is.
Have you considered the condition variable offered by SeaStor?
What? Can you repeat?
Sure. Have you considered using the condition variable offered by SeaStor?
Condition variable.
Yes.
I didn't find the proper functions from SeaStor. Do you know?
Okay.
Or anybody know any kind of functions?
How about this? We can continue discussion in at the end of the meeting, and I'll try to investigate some way to implement the counterpart of the queue or non-queue implementation to fulfill the requirement along with you, and we can schedule another meeting.
Yeah. So Yeah, my question is, if we remove the queue, all the queue,
Mm-hmm.
the one operation will be stopped there, and the return future, and we can fulfill the future later when condition is available, but all the task is scheduled by SeaStor reactor, and
Yes.
the other jobs cannot continue on the same path because we need another interest for the other tasks.
No, I don't think so. Because by task, I think presumably I think what you mean is the operation
Um,
from the same client, right?
not for the same client or for the same operation. It's for the some OSD its own task. For example, there has some PT collection, save to storage, something like that. They have the OSD as data has a context queue. So when they check something not available, they can do what's that? They can do handle on commits or something like this kind of work.
Okay, probably you can put it aside and we can discuss it later on,
Okay, okay.
and
Yeah. That's
we
I
can
want
finish
to
this, get an
discuss you.
update. Sure, we'll do.
Yeah, discuss first, then I can continue writing the code because it's according to
It's,
the how to design the.
yeah, it's a blocker. I understand.
Okay.
About how to whether to implement or implement queue or not. I think I have maybe an example related to this in the messenger. So previously, if we want to write a message into the Crimson Messenger, we change the future of the send ready, right? If you read the
Yes.
code,
Yes.
the writes are chained by the send ready, but and I modify the code to first when send the message just in queue this message to our STD queue, and then dispatch a write event logic to dispatch all the messages to the out to the socket. The related patch is here. Oh, basically it just add a queue instead of chaining futures together, and I tested the performance. The result is with the unit test, the ping pong implementation, it is 3.7 times better. So maybe it can
Yes.
help.
So with Q we have better performance, right?
I think it depends, maybe because the message, if we enqueue the message, we can let the write event to reap all the pending messages together to form a very large buffer and then send out together. I think that's why it is faster, and there will be much less continuations on the fly. So that's why it is faster. There's only one dispatch event that will run again and again, but they don't chain together.
Okay. I will refer
Yeah,
your
this
patch.
is related. Maybe there will be some hint behind it for OSD design.
So basically, it's still using the queue underneath, and when we need to rip the queue to collect the message in the queue and send it out.
At the at the open state, the write event, this function will be called every time when there's a new message or there's a new write keep alive or keep alive act. But
what if there's no message triggers to nudge the socket? Will the event or the messages
because
they stay in the queue for forever?
Each write event will clear the out queue. When it finishes, when the write event finished, this function finished, the out queue must be cleared. So there's no need to dispatch write event again. So only after there's a new message or there's a new keep alive or keep alive act, the write event will be dispatched again.
By new message, you mean whenever a new message is received?
Send a message. Yeah.
But what if there's no message? Connection send. So whenever we need to send a message or receive a message, the write event will be the method of write event will be called, and the queue, the message in the out queue will be dispatched.
Yeah. So yeah, because write events may be slow because there may be a lot of message to send, and at this moment, if there are more messages incoming, the new message will only be enqueued, and the write event will read them all until the queue is empty.
Okay, I'll take a closer look at it.
And the performance looks much better than before.
I think regarding to the OSD op, we can, if we decide to use the queue, we can always to execute the pending operation in the event in the same thread where we fulfill the precondition. But anyway, we can discuss it later on after the update.
Okay.
And Jianpeng.
I still focus on the performance between the single message and the SeaStor message. Last week I did some tests. I limited the client ROPS and using proof to record the SeaStor. The SeaStor include SeaSread, SeaSend message, and SeaEpo wait or pwait. And from the result I found in a single message, the SeaStor read and send message are more than the SeaStor message. From the proof problem, I think in SeaStor, depend for SeaSread, SeaStor using the buffer size is double timed than the single message. So the SeaSread is less than the single message, but and in SeaStor, the bunch handle the send message, maybe bind the multi message into one to send. So there is less send message in SeaStor.
嗨，
But
建鹏， from the number seems a sync messenger use multiple sys read, right?
no, only one connection.
Yeah, but I mean the sync messenger the result you showed a sync messenger has more sys read, but why you say it less?
Yeah. This is wrong.
Jim, I'm reading your mail. I'm quoting it in the chat. What do you mean by read 0x2000? Does it mean the size of read or the number is read?
Yes, the in
So
a single message.
It's read in larger batch. Is that what I mean?
Yeah. So because the buffer size is larger in SeaStor, so there is less this read syscall in SeaStor.
Okay, so Crimson Messenger reads less, right? Reads less than a sync messenger.
Yeah. At the same IOPS, because I first limited the client IOPS.
And also it
Okay.
write less because it has a larger write, right? So it tends to write larger bunch of sizes of data to this write. 建鹏?
Yeah. But there is the other question in SeaStor. There is more epoch control and epoch weight very larger than in a single message.
So it's more frequently than
Yeah.
messenger does. Okay.
And I found I limited the IOPS to 5,000. With the SeaStor message, the CPU core is nearly 100%. So I
You mean
think
the CPU
maybe
usage, right?
yeah. So maybe with the wrong SeaStor, or the SeaStor is not maybe SeaStor refactor using Paul using not use interrupt.
Yes,
So the
SeaStar use epoch for all the I/O and the system call.
but epoch is event driver. If there is only 5,000 IOPS, the SeaStor call will use nearly 100. So this is
Yeah, it seems that it's running a busy loop out there.
yeah. Maybe we with wrong SeaStor, or there is some other parameter to configure. I don't know.
So I saw Yinxin send out his test result.
Yeah.
That result seems very better.
I think 建鹏's point is to say about even though the overhead is very low, the Crimson Messen the SeaStor framework always take 100% of CPU power. It means it will consume much more power.
Yeah, they have a recacher and engine running all the time.
Yeah, even under less overhead.
That
That's
is
the
another
reason.
question. Go on, Redok.
Sure, that's the reason why only the 100K IOPS samples are interesting. Take a look. Also, the SeaStor, also the async messenger was taking there the whole core. So I wouldn't be too much interested in the samples from the 30K limitations.
What do you mean by 50K scenario?
Understood. There was two test cases. One test case was we was imposing limitation on the client to not generate more than 30,000 IO operations per second. Second one was the limit was set to 100,000 IO operations per second. And for the first one, we can see that the SeaStor messenger was utilized only half of CPU, which is expected, I would say. The Crimson messenger has taken the whole core. Still expected in SeaStor, we know that even if there is no I/O, whole core will be consumed. But the proportions are much more interesting for the 100K test case, because I guess we have apple to apple comparison. Both messengers have saturated CPU.
But when Crimson Messenger is idle, it also take 0%, 1% of CPU. But when there's a little overhead on it, it will consume 100%. There's nothing in the middle from our experiment. It's just very low or very high.
Either 0 or 100. That's an interesting finding.
So can we ask can we ask this question? Is SeaStor development mail list?
Can, but I'd suggest we do our homework first to understand what is going on underneath. Well, if I recall correctly, the reactor is doing some kind of busy loop out there, waiting for an event or waiting for a task.
Yeah, seems like. Okay, so we can do our work offline for this question, and I have questions for the Yinxin's test result. So it seems our comparison.
I can share it now. Let me see.
Yeah. So do you have the latency result number?
I think I need to install the extension to Chrome. Let me see.
Oh, there's latency. No, this is Jianpeng's latency. No latency.
Share screen. Screen shared. Okay, can you see my screen?
I can.
Okay, so
Yes.
The first thing I need to say is that I implemented another test tool because current FIO test engine can only work with asynchronous messenger client. So I'm writing this because I want to do pure chromosome to chromosome performance check, to performance test. So this is the first thing I did, and then this is the performance. So that's why we can compare the performance of chromosome to chromosome and async to async, and compare different scenarios.
Excuse me, Yingxin. So
Okay.
this crimson async to async is still use your test tool?
No, async to async is using FIO because according to our understanding, the FIO asynchronous with the FIO engine with asynchronous messenger is the fastest test tool.
Okay. So the crimson to crimson is use our tool, and async use the Jianpeng's used tool, right?
No, crimson to crimson is what I pushed in the chat here. Is implemented separately.
Crimson to crimson is our own tool, and async to async is a tool as what Jianpeng used.
Yes, it's FIO with asynchronous engine, and the server is just asynchronous messenger that replies with the OSD OP reply directly.
Okay. So
because using FIO, it is difficult to integrate crimson messenger. It will. I think it may submit to the alien world, maybe between the alien world and the POSIX thread, and maybe there's some performance overhead there. So that's why I think I need to implement our own client for crimson messenger.
That's why I ask this question. Maybe our tool is more effective.
I don't quite sure, because I think FIO is quite efficient from our test result. If you see that the remote case, the crimson case and asynchronous performance are almost similar.
Yeah.
If with QDAPs are with max QDAPs and the block size is 4K, and the two client and server are in different hosts with 10 gigabit network, the performance is very similar. But we have other
better if the block size is like 512 bytes.
Yeah, because the write sizes are smaller, so that means the more messages, and means more overhead to the messenger itself.
So batching the writes would help. That's why that's the reason why you put a change in the crimson messenger to try to batch the write. Is that true?
Yeah, no, not exactly, because we have many messages to send, and maybe actual write socket is not quick enough. So if we just chain feature together, there will be a lot of continuations pending and pending there. That will be a huge overhead there to the reactor. So instead, we just enqueue it and then finished.
Okay.
So there will be no overhead.
I agree.
So it's more like offload the queuing work in the application level instead of doing so in the SeaStor framework level.
Otherwise the reactor, there will be many tasks to schedule, and the overhead is very heavy. Yeah,
although the continuation is faster than context switch, but it is slower than the queue.
Yes. And still has the instructions cache also missing if there are so many futures pending there.
So,
So if
so the
we
thing,
use the queue, they can process the operation. How to say
yeah,
it?
it means
Bunch.
the queue is the fastest. The simple queue is the fastest
Yes,
approach.
I agree. I agree. So
Yeah. Yeah.
Okay, so I just investigate the.
This is still one connection, right?
Yeah, yes, still one connection. And the strange part is if we put client and server in one host, the asynchronous messenger will be slower if they are remote, and the Crimson messenger will be much faster. This is one strange part here.
Okay.
So we can see cloud remote here.
That's funny.
So Yingxin, did you check the request send in parallel?
Yeah, request is sent in parallel because there is a queue depth here to control the parallel requests, the in-flight requests, the number of in-flight requests. So the requests are always sent in parallel here.
Yeah, queue depth is sort of the number in parallel.
Yeah.
That's how that's a term of how FIO say the term of FIO. That's the parallelism in FIO. That's queue depth.
So the finding is here is the local one is much faster than remote one with Crimson, but not with asynchronous messenger. And if the write size is much smaller, means more messages,
So
the Crimson messenger will be faster than the asynchronous messenger.
Why the asynchronous messenger local is worse than the remote? It's not reasonable.
Yeah, I also think so, but I don't understand. We also see that the client server messenger are running in different cores. There are two cores running on 100%, but the actual performance number is not good with asynchronous messenger. And the third experiment is to limit the queue depth. So I think it means more about latency analysis. So if we limit the queue depth here to limit only a small number, so the message will wait for each other to complete. So that's why I think this number is more related to latency. So I think in the remote case, the Crimson latency is a little slower than the asynchronous messenger, because there is I think there may be some merging behind, merge small buffers to larger ones. It causes some more latencies.
Which one has more latency?
The Crimson has worse latency with the remote case.
Okay, I see.
But you can see much better.
SeaStor will do the merge underneath.
Yeah, because we see it from the SeaStor, the write size is larger, much larger than the asynchronous messenger.
The write buffer, right? Write buffer is much larger.
Write SeaStor.
Oh, the number,
yeah.
You mean the
size. SeaStor write size.
Oh, write size.
The Crimson messenger is much larger than the asynchronous. Asynchronous
we
just
see it by looking at the perf record instead of by inspecting the code, right?
Just look at the perf from the from Jianpeng.
Okay. Yeah, I see.
So when the block size is a little smaller, it's more good, right? For the remote and the local.
Yeah, because it means less overhead on sending the data, more overhead to process the message. So more overhead in the messenger itself, not in the operating system or in the network card or somewhere else.
Okay. So it means that Chrome Messenger handle the parallel task is more good, is better.
We can have a guess here, but
So I still has doubt on the async to async. Why the local is worse than the remote?
I don't know either. But it's strange.
I think what the action item is, the one thing is that we need to understand why there's no gray area when we put load on the SeaStor reactor, right? Is this is the zero usage and is this expected or anything we can tune or we are missing anything, and then we might, if there is no result or no answer to this question, we might want to send a message to drop a mail to the SeaStor devil. But before that, we need to do our homework.
I think it just means a very simple things here, that the simple queue is better than the continuation queue, and the continuation queue is better than the context switch. So if we can use queue, we should use queue, and if not, the continuation is much better than context switch.
I think the queue is better for organizing the task of the same kind, and the continuation is more like user space
schedule. Schedule different tasks.
User space scheduler, yes, for different kind of task.
Yeah. So
it's
that's
more general purpose. That's a text is paid.
So we should batch all the same task into queue, and let different tasks schedule with continuations. Maybe this is the best design we can have.
Yeah, I agree.
Yeah.
Okay.
Probably I need to take a closer look at your change and.
Okay. Another thing is here. Okay. So let me put here. This is proof here. I have a proof here. So I have 3 implementations in the messenger. So in the foreign dispatched case, I send the message always from a different core. So I have to submit to the connection core for each ping message, and the result is only 68K ping pong per second for the unit test. And the not optimized case here is that we queue the continuations for the writes, and we can see 142 is better than this one, but slower than we just put it in the queues. So that's the 3 performance numbers.
So you see the latest is queued the right message, right? Not optimized is change the future. What the foreign dispatch means here?
Foreign dispatch is that when the sender lives on another core, the connection must submit the message to the connection core.
Oh,
So
cross
that
to
means, there's
Yeah.
it involves a context, not context switch, but a cross-call communication here,
But it's more worse, right?
and it is the slowest. It is the
Yeah.
slowest one.
It's the safest
I mean,
and
I
the
mean
slowest.
I mean the cross call is more worse. Just the one communication, right? Just one communication, and it's more worse. It's about nine
Yeah, the tests
one
are the
night.
same. The tests are the same. It only establish one connection from one messenger to another messenger on different cores and send ping pongs.
Oh, what do you mean? For the latest one, is in the same car.
The latest is the optimized one.
I don't understand what you mean from two cars here. So
I
the
mean,
latest one
the
still
sender,
has
the ping pong server and the client are in different cores. They communicate with the socket. It's just our unit test of the messenger.
Yeah, but for the foreign dispatched, it's also
Yeah.
in the different cars, right?
No, in foreign dispatch case, that means in the client, the sender and the actual connection lives in different cores.
Oh. Okay. So you have two SeaStor threads for the foreign dispatch, right?
And Chunmei, I suggest you
Oh no.
you take a look at the mail sent to the Safe Devil mailing list regarding to the cross-call communication. And also you might want to take a look at the mail sent by Yingxin. I'm trying to find it for you.
Okay, thank you.
Probably you can have more background regarding to the cross-call communication and its overhead introduced by this approach, and why we want to avoid it, and why the SeaStor developed a suggestion against it, but we still want to do it. I'm trying to find it for you. Hold on. And at the same time, Reduk, what's going on your side?
Mostly working on V2 stuff, the on-wire encryption for Messenger V2. Yesterday on Monday I've sent a pull request bringing initial support for it. Let me find. Here it is. At the moment, I'm focused mostly on making optimizations there, and also on the security audit. It seems that I'm misusing the GCM mode. Need to make some changes. From the things somehow related to Crimson, I've pushed the amended version of the PR killing append buffer of buffer list.
Okay. Yes, I'm trying to get as much of your PR, as many of your PR into master before we have the feature freeze of the Nautilus for the Nautilus release. Because as you know, that Jason is trying to come up with the Liberators 2 compatible Liberators, and I'm not sure how it will work and how will the impact, how your change will involved with his efforts. But one thing I can assure that we need to get get as many as possible of your API incompatible change before we release Liberator 2 or Liberator 3, whatever
I see.
we want.
There is also one with quite small change. The last P elimination in buffer list. It needs rebase. I will dissect some time from V2 and push amended version quite soon.
I think I'll try to review your updated PR of the one I commented on and get it merged ASAP.
Why this PR have so many commits inside?
I think it's based on the wrong branch, I guess.
Okay, got it.
Presumably it should have like 20-ish or 30-ish change in it.
Yep.
And Yingxing, I found you have pushed a change regarding to simplify the cross-code, the compatible efforts of cross-code communication and one-to-one mapping.
Yeah.
Right. You have PR to address this issue, and I'll try
Yes.
to review it ASAP. And
Yeah, I
how's
think
it going?
it needs rebase now, and I will work on it.
Okay. Have it.
Yeah. So yeah, I think it is ready for merge, except for the rebasing effort. So please review.
Sure.
Take a review.
I'll try to get it done before the end of this week.
And another part I was working is the V2 refactoring. That's why I'm working on the write events, because it will abstract the actual write message and the write keep alive part, and while keep the general logic to dispatch the message.
Mm-hmm.
So that's why I'm working. So that's another part of the V2 refactoring here.
Yingxing, do you need some help from Ricardo or other hands?
Sure. So I'm glad that there will be someone to ask if I don't understand.
You can, if you can always grab because in the last core stand up I was raising my concern regarding to how far we are behind from the V2 implementation. The V2 implementation is pretty much in shape, and will be almost done before we roll out the Nautilus. And Ricardo was very, very kind to offer his help so if we need some help, he can help us regarding to the Chrome Messenger. So
yeah.
if you need any help, feel free to reach out to Ricardo over the main list or over IRC. I think he's very responsive over IRC, and he's always around. And his time-wise is in Europe, so he's very friendly to us.
So it's our afternoon, right?
Yes.
Okay. So another thing is So I also plan to submit a proposal to Sevalacon about the messenger with Jianpeng. So I will be send out the call for paper.
You need to do it.
Close.
Yeah, it's approaching the deadline. I believe it will be closed tomorrow, right? It will be closed in the end of January.
Yeah, I will be work on this today.
Yeah, you need to be.
Yeah, because
You have to be quick.
Previously I don't have so much performance data to present, so I don't think there's so much things to talk about. But so that's why this week I was mostly working on to get the performance, get some sense about the performance. So yeah, I think I will submit the proposal maybe today.
Yeah, actually, I think we can be a little bit optimistic regarding to the number because we will surely have some number by then if we keep going on in this speed, right?
Yeah. Yep. And the SeaStor is not working with the memory allocator. It's local. It's memory allocator, and we are using the self memory allocator. So that will be another performance optimization. We have better performance number if we change to SeaStor allocator, memory allocator.
Yes, I didn't expect this one. Yeah, that's a good finding.
And if we add more staging to our current implementation, so it may still a lot of room to optimize our implementations.
Yes, yes.
But aren't we using the SeaStar's malloc right now?
No, because the message reference is still not migrated to shared PTR and foreign PTR.
Well, I'm not sure. I guess it's orthogonal issue. I guess that we are just doing the
one-on-one
deallocation on not on the proper core, but still with using the memory allocator from SeaStar. It actually offers cross-core memory management, but it's slower, of course.
Okay. But if we only allocate memory from the local core,
Well, yep, it should be the management should have lower cost.
Yeah, we have better performance.
The same with eradication of the rest of the atomics. We have because of message ref and similar things.
Okay, I think that's all from me.
But by the way, in the case of in the case of single-threaded process, we can kill atomics almost automatically. All we need is basically wrapper over STD atomic. Something like Ceph atomic that would map plain operations for sister builds.
The rate of you are suggesting that we can have atomic in the safe namespace to hide the difference between one-to-one and M2N
Exactly.
difference, right? Okay.
Exactly.
Sort of like targeted by if-defined one-to-one mapping.
Exactly. That's the idea.
Okay.
We could apply this to buffer list. We could apply this to ref counted object of Ceph. Do all that atomic heavy stuff. And moreover, Intel CPUs has a lot of useful PMU events dedicated to tracking down atomical operations. To nailing down ping pongs, a lot of useful stuff in PMU. We can use perf to find any atomics on home paths.
Riddle, I'm still thinking about the idea of hiding the difference between one-to-one mapping and M2M mapping. My concern is more regarding to how if it will make the difference more. It helps to hide the difference, but my concern is that it might encourage us to ignore the difference between cross-call communication and non-cross-call communication.
The downside.
Yes, it's a downside of this.
I guess it's just an optimization. I think we should return to it after making a decision whether we want to go with one-to-one or with one-to-N.
Yes. Yeah. Yeah. We can come back to this and note it. I will try to note it down in somewhere so we won't forget it. And Jimpeng, I will try to get in touch with you regarding to the your change of shared RU. I still got some. I still cannot get my head around of it. I will send a mail to. Maybe we can have a short discussion offline.
Okay.
Does that sound good to you? Okay, thank you. And Chumei, probably we can try out the queue approach and to understand how we can continue resume the pending OP. I was thinking about that and drop a mail to the server table and copy you, so we can continue on the discussion to see if we can come up with a better idea and have a more specific design to address the problem.
Okay,
we
thank
need
you.
to put more thought on it for sure. And Yingxing, I think the next thing is to for sure is to send your proposal to the CIFRCon before the deadline. Yeah. And I think the next thing is to I will need your help to get your change reviewed and then to catch up with the progress of V2 implementation.
Okay.
Kefu, one question.
Yes.
In our design, we still have the OSD service, right?
Yes, I think we do need to split the part of OSD functionality into a sharded service, which will be used by PG.
Not the sharded service. I mean, in
Not
the
necessarily
existing
sharded.
code, in the existing code, there is a OSD service, and use that service to get some OSD map or something like that.
Yeah.
We still have that class, right?
Currently we have a OSD class, but we don't have a OSD service or OSD map service class. But I think it would be ideal if we can extract such kind of functionality out and expose the service to PGs.
Oh, okay.
It's more the functionality wise it's ready, but we can refactor it a little bit, expose as a service, just like how we did to the config proxy and performance counter.
I mean, we still need that kind of service, right?
Yeah, we can. We need it, but what I mean is that the service is already implemented, but it's not exposed as the sort of like a global variable or something. We always need to pass the OSD pointer down to where it's used. For example, we have a PG, or PG backend, or the the OSD meta where the OSD is consumed, but what this consumer needs is but a service which can offers the OSD map, right? So we can refactor based on the existing implementation, but functionality wise, it's ready.
Okay, I see.
We can discuss the interface later on. Okay. Are we clear? Are we good? Any further questions? Okay. Thank you guys, and talk to you guys later.
Yeah,
you.
next
See you
week is
later.
the
Bye.
New Year, right?
Oh, yes. Oh, I
Have
forgot.
to skip once.
Yeah. The next, I think the next week would be the Chinese New Year, right? So
Yeah.
we will have a one week break.
So
And,
Yixing,
I think
can you guys come back the week after next week?
I will come back the week after that, but I will not available the next week.
so you will be off in the following 2 weeks.
No, I will be available in the next week, but not available in the following week.
Yeah.
Okay.
So we only skip once.
Yeah, skip 1 week. I have 1 week.
Do you plan to have an extra holiday aside from the next week? Or I guess so. So we will.
Are you available on 12th February? 12th February. You skip two times or one time?
Okay, and I think we will have 1 week off for the Crimson team, and we will skip the next stand up. And, happy Chinese festival, and talk to you guys the week after next week. I will cancel the next
Nice
meeting.
holiday.
Thank you.
Thank you.
Bye.
Talk to you guys later.
Thank you.
Bye.
Bye-bye.